massive scale collaboration, collaborative editing and collaborative writing platform, I wanted to provide a little background about why I'm working on this problem. So let me start off by what I'm doing in Korea. So my wife and I used to work for Microsoft Research for about 9 years. And she had an opportunity to come here. And so we moved here. She started working at Samsung, and my kids started going to an international school, and I was working with startups and watching all of the political goings on in the United States. And back in January of last year, of 2017, some people started, in response to the political changes in the US, some people had the idea that they should have a March for Science. And a friend of mine was on this group of organizers and gave me this very nice invitation, along with many other people, to join the set of organizers for this political protest. And I was very honored and very excited. But I probably shouldn't have been so honored, because the invitation to join the group of organizers wasn't as exclusive as I thought it might have been. By the time it was a Facebook group, and by the time I was added to it, there were 50,000 people on it, all on this list to try to organize this protest. And then the next day, there were 500,000 people, 500,000 people on this organizers group. And this would be a very interesting size of group to try to organize something with, but there really weren't tools for that. And so what happened was the original few people who had the idea and put together the group realized that the group couldn't be useful for anything, that you can't get anything done with 500,000 people. And so they quickly went back and created a smaller group of just a few people, and that group was going to write the mission statement and make all of the decisions about why 500,000 scientists wanted to march on Washington. And so instead of having this mission statement organically come out of the scientific community, it was a small set of people who came up with all of the reasons that the group would be marching and what the political goal was, instead of the 500,000 people. And this seemed a little disappointing to me. I thought, wow, they have a lot of brain power here, right? Think about this as a computer scientist. You have 2 to the 19th processors with these great mental capabilities. These are people who write academic papers. They know how to communicate information. They know how to communicate ideas. They know how to work together. And this incredible cloud of brains is being left to sit idle, doing nothing, because we have no idea how you could harness it for this type of work. How could you write a mission statement with 500,000 people? And so I went off and I thought, well, how would we solve this problem? And so I looked at what existing technologies were out there and how they worked. And one of the existing ways that when you think about the existing ways that we build collaboration systems, I found it useful to think about how do we choose who gets to make changes and who approves them? And so understanding what model might work for 1 million people or 500,000 people to all write a document, it's helpful to think about these questions as you look at the existing models. So one of the models that people like to talk about are wikis. Wikis are very successful for very large things if you can divide them up. But on an individual level of a wiki page, the rule is that the last writer wins. And then with Wikipedia, they add some other rules, like you can't make the same change 3 times. And if there's a conflict, they have a whole army of people with a hierarchy that can come in to help fix it. But the key rule is anyone can write, and it's just the last writer wins. And Google Docs is similarly anyone can write at the basics stage. And there's, of course, a lot of other platforms like Google Docs where you can have a number of editors, 3 or 4 people. It generally doesn't scale past 10, where you can all be writing to the same document. And the rule here is it's what we call unilateral collaboration. Anyone can make a change and do something without asking anyone else for permission, and the change just happens. The problem with that, of course, is that you could have people trying to work on the same sentence or same line, and they're going to conflict, and they won't be able to do that at the same time. And as you grow the number of people, they're going to start bumping into each other. And even if it's a small group of people, they don't always approve of the changes the other person is making. So a few years ago, Google added a feature to make it a little bit more like GitHub, where you can suggest changes and someone will approve them. So in Google Docs, it looks something like this, where I would suggest we add this sentence, and then someone has the ability to change. And so we call this oligarchical collaboration because you have a few people who have the power to change the document, but everyone else can only make suggestions, and they have to be approved by one of the two or one of the small set of people who is capable of going through and checking the suggestions. And sometimes people are happy with the way this works, and sometimes they're not, because there are going to be people who make suggestions and it's rejected, and they don't know whether it was rejected because most of the people won't actually like it, or just because the one person who's in charge who got to click the button didn't like it. Similarly, they may be upset because there's something that they thought the group wouldn't like, and it got approved even though most people wouldn't like it. Some of the other problems with this approach is that even if people were happy with it, once you reach a certain scale, then you've scaled the number of people who can make suggestions, but you don't scale the number of people who have to read the suggestions. So you might get maybe at best an order of magnitude improvement in the number of people who can be working at once. And that's under the assumption that it takes you 1/10 of the time to review a suggestion as to come up with one. But it still doesn't truly scale beyond a very small number. And so with this approach, you also run into lots of limits. There's another approach has come out of the research community, out of MIT and Michael Bernstein, who later became a professor at Stanford, where they've built crowd-based systems to do editing. There's a system called Soylent, and that system will assign people who are workers to go and try to improve a small part of the document, and then assign other workers to report back on whether that was an improvement or not, and whether the change should be made. But in this type of system, the participants aren't people with a stake in the document, they're paid workers. So they're doing this as a job. They're being asked, we'll pay you 20 cents to come up with suggestions and do a few votes. And so they participate in the system as workers. You're not trying to get to something that everyone likes. You're just trying to get to something that is an improvement over the prior one, where people are sort of cogs in a factory. They're on an assembly line. They don't get to contribute ideas anywhere they want. They have to do what the system tells them to. And the reason they're willing to do it is because they're getting paid. Sorry, I spoke over those already, but yeah, it's not really true collaboration as it is a way to automate the process of lots of people helping improve something. So how could we make it possible for a really large number of people to all author a document together? We propose an approach which is what we call, in the general case, multilateral collaboration. So in multilateral collaboration, everyone not only is involved in making suggestions, but the suggestions aren't approved unless we have some consensus, not necessarily of everyone, but of enough people that we feel like this is a good change that's approved by more than just one person. It has some greater level of support. And the specific implementation that we're working on is what we call democratic collaboration, where it's a voting process, and we want to make sure that we believe there's a majority that would support something. We may not measure the whole majority, but we want to make sure that we're fairly confident the majority of the group would support a change before we make it. And so just like before, every author has the opportunity to suggest. They can propose changes. It's different from, say, the way Google Docs does it, in that you propose a set of changes that are all needed together to make the change consistent. So if you're changing language in the first paragraph that also affects language in the fourth paragraph, you'll combine those two changes to make one proposal or one suggestion. But then every author also, and this is where we differ from the previous systems, is every author also has the equal ability to determine what changes get made to the document. And they're able to do that through this voting process. And let me show you a little bit about what that looks like. From the perspective of the person doing the voting, they see a copy of the current version of the document modified with the change illustrated. And then they just decide, do we want to keep the change or discard the change? So we want a very simple decision, a binary decision. Is it better with the change or is it better before? And so their job is to look at the changes and then just click one of those two buttons. And we want to keep it as simple as that for all decisions, so that there's, from a user experience perspective, it's really as simple as possible for them to understand what the decision they're making is. And so with that kind of decision, we can determine, is this change worth making or not? We can also use it if there are conflicts, and I'll get to that later. If there are two changes that can't both be made together, you could show the document as if one of the changes had been made, and then show the change set to get to what would happen if the other set of changes had been made, and have the user decide, well, would I prefer change set A or change set B, by looking at a diff and deciding whether before or after is better. So the expected user workflow for users using the system is that they're going to be doing three things for each version of the document. They're going to look and see what the current version looks like, and then they'll have a chance to draft and submit proposals to change the document. So go into the editing mode and create changes that they'd like other people to approve. And then this process of reviewing and voting. Until the voting is done, we know what changes will be made. The changes get made, a new version is released, and this process starts again, and it iterates over and over. And one of the nice things about this process is, since it is iterative, if we make a mistake, the consequences aren't so bad. Because if something gets approved that maybe shouldn't have, it can get fixed in the next round. Or if we change something that's slightly inconsistent because we didn't realize there was a conflict there when there actually was, it can get fixed in the next round. So having an iterative system gives you a little more ability to fail and still be okay. So let's look at how this exactly works. So examining the latest version of the document looks something like this, where you can see what it looks like, and you can also check out how you got there. So what are all the diffs between the previous version and the current version? The second part, drafting and submitting proposals, looks very much like a standard editor, except it's not like a Google Docs in where you would see other people's suggestions, because there might be just way too many suggestions for you to process. So all you see is the current version of the document, and then you just edit it as if you were in an editor without seeing at all what other people are doing. You can just focus on the change you would want to make. And then when you're done, we show you a diff of what the changes you made were, and you can submit them, and then you can go on to this process of reviewing and voting. And to illustrate the process of reviewing and voting, we have a little recording here of what it looks like. You have to step through all the changes to make sure you've seen them before you can accept. And then if you're voting keep, you vote keep or discard, and then we load in the next election that we need for you to vote on. Okay. Now, in order to, so this is the workflow that we expect users to go through, but the actual workflow is that they can do anything of these three actions that they want. If they want to review some changes and then they see something that they, and vote, and then they see something they wish they'd done, they can go and draft and submit a new set of changes. If they're in the middle of reviewing and they've forgotten what the original version looks like, they can go back to viewing the original version. So while we have this process we expect them to go through, anything really goes. They can go anywhere through these three steps. Now, in order for us to release a new version, there are some conditions that have to be true if we want to have something that's consistent and make sure we only accept things that the group wanted. So we can't just take all of the proposals submitted. We obviously want only the proposals that people liked. So those that we say are preferred to the alternative of leaving the document unchanged or just not taking any action. So we call this the preferred to inaction set. If something is not preferred to inaction, that means people would just prefer the document to be left the way it is rather than make that change. So these proposals that are outside there in the Venn diagram we would not want to allow in the document because people didn't like them. Then there are some other proposals we're going to have to leave out because they conflict with proposals that we do want to accept. So we have to go through the proposals that people liked, identify things that are conflicting, and then resolve those conflicts, either by taking only one of the two proposals or finding a way to merge them together. And so we're going to have to, at some point, stop allowing submissions if we're going to be able to get our system to the state where we know that there are no longer any conflicts. Because if we didn't stop people from submitting changes at a certain point, we could have the following scenario. We have two proposals with conflicts, A and B. So we start an election to see which is better. A is about to beat B, and we're about to create a new version when someone submits a proposal C. And when someone submits a proposal C, that proposal conflicts with A. So now A's beaten B, but now it has to beat C before we can decide on whether A or C should be accepted. So we do an election between A and C, and right as A is about to beat C, D comes in, and D also conflicts with A. And we could end up in this state indefinitely. And while it's unlikely, it seems unlikely that this particular scenario would happen, when you think about 500,000 people submitting proposals, it's very unlikely you're ever going to reach a state where there are no conflicts unless you take a break from accepting proposals in order to resolve conflicts. So for that reason, at some point we have to say we're going to stop accepting proposals at some point and impose a deadline on when proposals are due. And we don't necessarily need to do that immediately. We can wait because we don't really need to create a new version until we know there's at least one proposal to change the document that people like. If there's not a proposal to change the document that people prefer to doing nothing, then we don't need a new version. So we don't have to set a deadline until at least one proposal reaches this state of having received a majority of people who are in favor of it. And at that point, we know we're going to want to create a new version. And so at that point, we impose a deadline. Now, we're going to choose a deadline that balances the desire to quickly finish up this version with the desire to give people who are in the middle of working on a proposal a chance to finish it up. So if nobody's currently working on creating a new proposal, we can impose the deadline now and possibly create a new version right away if there are no proposals that are in an unclear state. If there are lots of people working on changes that they want to propose, then we probably want to have a much more generous deadline. And so it's through this process that we can end up with a deadline that allows us to then go and resolve all those conflicts and get to that non-conflicting state. So before I get into questions on how we resolve conflicts and scalability and human factors, are there any questions about sort of the basics of how the system works from a user experience perspective? Okay, great. So how do we make this scale? I think the number one concern you would have thinking about a system where you need a majority approval to make a change is that it will not scale in a good way, right? The number of votes you need, if everyone can make a proposal, and if everyone does make on average one proposal, the amount of work is going to scale as a factor of x squared, where x is the number of people, each making one submission, and then all needing to vote with a majority to decide whether each one is accepted or rejected. And so from a total work perspective, it's x squared, but more importantly, from the standpoint of any one of these individuals, it's going to grow, the work is going to grow linearly. For every proposal that I submit in a group of 10, I have to do 10 votes. In a group of 100, I have to do 100 votes for every proposal I submit. And then in a group of 1 million, I would have to do 1 million votes. And so that's not reasonable. That's not the kind of scalability we would want, and it would lead to a terrible user experience. So what we'd really like is something more like this. Given that you can review something in about 1/10 the time it takes to write, I'll spend about 20% of my time writing and about 80% of my time reviewing if we can get the system so that after a certain point, the curve flattens out. So roughly, we'd like it to be around 50 votes for everything I propose. And the way we can do that is using sequential analysis or sequential hypothesis testing to statistically sample whether we believe a majority of the group supports a change or supports one direction over another without sampling the whole group. So the way sequential hypothesis testing works is that we have two hypotheses. In this case, one hypothesis is the majority of the group is in favor of the proposal, and one hypothesis is that the majority of the group is against the proposal. And each vote is a test. It's a data point that either supports one of the hypotheses or the other. And so as each vote comes in, we move closer to certainty that one of the two hypotheses is true. And then we can stop the vote the moment that we have enough data points to make a conclusion. So we can use the minimum number of votes possible. And since people's time voting is a scarce resource, we want to minimize the amount of that resource we have to use in order to make a decision. And this comes out of statistics from Wald back in the 1950s. So this is a very old technique. One of the neat properties is that if both hypotheses are equally likely, the step size is the same. So when you think about what kind of election or what kind of rule would implement a sequential hypothesis test, it's actually equivalent to a win by n rule. So the moment someone has a lead by n votes, we make a decision. So it's something that's not only based in it not only has a rich background in statistics where we can lean on that mathematical formalism, but it also translates very nicely into something that people understand. People who play sports often have a rule that a contest is over when someone's leading by a certain amount and you move on to the next one. The one problem with this approach is that the less people care about a decision, the more votes you need, which is bad. Right? It means that people are going to spend the most time voting on things that the group cares the least about, because those things don't converge to either side. If 51% of the group is against a change and 49% of the group is for a change, you might need a very large number of votes in order to determine something that people really didn't care that much about, or at least that the group as a whole was very indifferent towards. And so at some point, you're going to want to cut off the number of votes and just say, you know what, we're going to take whichever one's winning at that point. And you don't necessarily want to do it at an even number. You probably want to do it at an odd number so that you actually get some kind of outcome. And as I said earlier in the talk, this process is iterative. So we're all going to vote, get a new version, and then we can propose changes and vote again. So for things that people didn't care about too much, if someone was really passionate about it or thought they could do much better and get everyone on their side, if we get this wrong, they can fix it in the next round. Okay, and so through that process, we call them the micro-elections. Through that process, using sequential hypothesis testing and statistical sampling instead of asking the whole group to vote, we're able to get the number of votes that you need per election down to a small, reasonable number. Now there's the question of how do we resolve conflicts? So you've got two proposals that were both popular. People voted for both that they were preferred to doing nothing. And so what do I mean? First of all, let's clear up what I mean by a conflict. So here we have a conflict, which is this text in this version. This is proposal A, is to add the word real before conflict, and proposal B is to get rid of what is a conflict. So if we were to take these both, we would have the problem that this is being inserted into text that's being deleted. We can't do both. Or we could do both, and it wouldn't make any sense if we deleted and then just put this word real there. Another example of a conflict is when we have a substitution. So we're substituting here the word what's for what is, and we're substituting is this over here for what is. And if we were to apply both of these changes, you'd get something that was grammatically incorrect and incoherent. And so when you have something replacing something else, it needs to be consistent or you have a conflict. So if we were to try to figure out, if we had 1 million proposals and we wanted to find out whether they had conflicts, the naive way to do this would be to just compare all the proposals to the other proposals. But that would then be an n-squared algorithm. So again, we would be creating a scalability issue where we would now have 1 trillion comparisons to do. And I know that if you're a company the size of Naver and you have a big data center, yeah, you could do you could do 1 trillion computations, but it would not be the most efficient way to do it, and it would certainly be a lot slower than the more efficient ways to do it. So, right, you would end up with just a very large computational load. So what we need to do in order to calculate where the conflicts are is that we track at any given point in the document which of the proposals are currently deleting something, which are currently inserting something, and which are currently substituting. And we also track moves. And then we know that of the set, there will be conflicts between the set that's inserting at a given point and deleting and so on. And so tracking that is a much more efficient thing to do. The worst case is that it's the number of proposals times the length of the document. That would be for the really evil case where each proposal is to delete the first character, insert a character, delete a character, insert a character. So that doesn't actually happen in reality. And if it did, you'd still be okay. In reality, you're going to be much more efficient than that. Whereas with the naive approach, you're stuck in that n-squared case no matter what. So now the question is, well, what happens when we have conflicts, and how do we resolve them in an efficient way? And so let's, for this, it's illustrative to assume the case that we have 4 proposals and that they all conflict. Let's look at our worst case. Everything conflicts with everything else. In that worst case, what we could do is we could see which one would win between A and B and which one would win between C and D, and then find out the winner, and then keep resolving until we're left with just whatever survives. So this should look like a tournament, and the same thing we'll be doing at the Olympics. And with this process, you're guaranteed that you'll converge, and you'll converge efficiently. And when you compare an A and B, you might choose A, you might choose B, or we could choose to have some default merge mechanism that merges A and B in some meaningful way. But at the end, what's key to this approach is that you always reduce the number of proposals that you have to process in half. 2 go in, 1 comes out, even if it's a merger of 2. And if you do this, then you have a recurring Taylor series that converges to just under n. So you're going to need at most n elections if there are n proposals that all conflict with each other in your worst case. So the way this looks in practice is we have a bunch of proposals. We send them out. Whenever we have a proposal added to the proposal pool, we look for conflicts. If there's a conflict, we send it out, and we see which one of these will win. And then when there's another 2 proposals that conflict, we send them out and see which one will win. And these elections take place and let's say A is chosen over J. A goes back into the pool, and we see if it still conflicts with anything that's in the pool. Here, A still conflicts with D, so we have A and D, and we go off with that election until eventually we reach a point where we've resolved all the conflicts, and everything that's left in the proposal pool is non-conflicting. And at that point, as long as they're all preferred to an action, we can go and create a new version. So the thing I left out was, how do we deal with new proposals that we don't yet know if they're preferred to an action or not? What we already talked about, the most basic thing is to just test to see whether that proposal is better than leaving the document as it is. But there's another thing we could do, which is if we already know that A and C are preferred to an action, and we know that E conflicts with one of those, let's say it conflicts with A, then instead of comparing E to doing nothing, we could compare E to A. And we know that if A is preferred to doing nothing, and E is preferred to A, then E is preferred to A, and A is preferred to doing nothing, then by transitivity, E is preferred to doing nothing. And so we can save ourselves one election and just jump straight to E versus A. So our final proposal selection algorithm uses this process to move proposals from a state where we don't know whether they're worth doing to a state where we know that they're preferred to an action, and then removes all the conflicts until we can get to a new version where everything's, conflict-free. And the worst case, when you add up all of the elections you would need, would be 2n elections. So let me move on to talk about human factors. How do we keep the people participating in this system happy? How do we, other than, of course, making sure that they don't have to vote too much for everything they propose, how do we deal with some of the other issues? And one of them is how to present 3 options. So initially I said the only thing users were going to have to do is decide when they're voting is to decide whether to keep changes or discard changes. But then I said we wanted to be able to have this merge option where if you have a proposal A and a proposal B, instead of choosing between them, you could also choose this third thing, which was a default way of merging them. That's a choice with 3 options. So that doesn't lend itself immediately to just keep or discard. But what we do is we split it into 2 elections so that we can do keep or discard. So when there's the 3 options, we first say, okay, which would you do, A or B, where the user is shown either B as the original and A as the set of changes, or A as the original and B as the set of changes, and votes to determine whether they prefer A or B. And then we tally up how many preferred A and how many preferred B. If they chose A, we then ask them, so would you keep A the way it is, or would you merge it with B, where you keep the changes from B, but you also keep the changes from A, using the default merge algorithm. And if you would and then we assume that if you choose merge, that means you prefer merge to A and you preferred A to B. Similarly, if you chose B, we'd say B or merge. And we take the number of people who chose merge in that second round and we add them up. And if more people chose merge than A or B, then we do merge. If fewer people choose merge than A or B, then we choose whichever they preferred between A and B. In that way, we're able to have users choose from 3 options, even though at any given time they're only seeing 2, and are still able to preserve that very simple requirement that users should only ever have to choose between keeping or discarding a set of changes, because trying to keep 3 versions in your head at once would be really hard. Okay, now users are going to have lots of biases, and we need to design the system to try to remove their biases to make it as fair as possible. For example, they might be biased in favor of their own proposals. They might be biased in order to conform with the group, so they may want to just vote for what everyone else is voting on. That's sort of the lazy, easy thing to do. If something's leading a vote 5-1, I'll want to vote with a 5. Or they might be wanting to vote counter to everyone. Or they might be in favor of changes. They might think, well, the document, I don't like the document the way it is. I want to just take all the changes. Or they might think, I like the document the way it is. I don't want to take any changes. So we need to try to remove as many of these biases as possible. When people vote, they get to see what they voted on and how many people voted for it and how many people voted against it. But for the thing they're voting on right now, we actually don't show them any information about who wrote the proposal, how many people have voted for it so far, how did they vote, or even what's the identifier of this proposal so that you could know, oh, this is proposal 2.7, my friend wrote it. You don't get to know any of that. You just see the diff, and you just get to choose keep or discard. And only after you do that do we show you the data that's down here, which shows what you actually voted on. So we do that to remove biases. Another thing we do to remove biases is that you might have a friend say, hey, can you go vote on proposal 2.7? Well, you have no control over what you're voting on. You get assigned things to vote on at random by the system. So in order to remove the bias of people trying to game the system, and in order to remove people trying to collude and protect against that, we assign elections to people at random. So we have a set of elections that are open and that need more votes. And when you have something new to vote on, we're going to pick one of those for you and then show you the diff and ask you to vote on it without you knowing what you're voting on or who wrote it or anything. So it's possible still that someone could say, hey, I changed this word in paragraph 3. Can you please, if you see that, can you please approve it? But you're going to have to actually look in the diff to recognize it, because you can't just look for the proposal ID or who the author was or any of that other information. And things are being given to you at random, so you don't know what was given to you unless you inspect it. Okay. There's also the possibility that preference is correlated with voting speed. You can reject things more quickly than you can accept them because you can't accept changes without having stepped through them all. And so we have to protect against that. And in order to protect against that bias, we make sure that a minimum fraction of those to vote on something have voted before we make the decision. So if we assign 6 people or 10 people to vote on something, if we assign 10 people to vote on something, we'll make sure we get to at least 8 of them have voted, or some number have voted before we make a decision, so that we're not going to just go with the early voters who dominate. And lastly, and I think most importantly, is that as the number of contributors to a group grows, the less opportunity you're going to have to change the document. And the more other people are going to be voting, the more likely it is, and the more other people are going to be proposing changes, the more likely it is that someone else's idea may beat out your idea, that your ideas might conflict with other people's ideas. So even if they're good ideas, they may lose out. And so the larger a group grows, the smaller everyone's influence is. So we need to make sure people feel good about the impact they're having, even when they're just one person in a very large group. And so what we do is that we tell people exactly how many of the words that they wrote got into the document, which is a little helpful, but is going to go down as the number of people increases. But we also tell them how many of the words they voted for made it into the document, and how many of the words they voted against didn't make it into the document, so that they understand they're having an impact even if none of the words they wrote made it into the document. They're still controlling the future of the document and having an impact. So that sort of finishes up what I wanted to cover. And with that, I would love to take any questions you might have. Thank you.
Do you have any demo or any services that we can just take a look?
Yeah, everyone has laptops. We could do a demo right now.
Okay. You're first.
Let me just go to revisolution.com and sign in, and then create a resolution and tell us what the link was. Or I'll create a resolution and you can all copy the link.
So you have to create an account, right?
Yes, you'll need to sign in, and let me sign in. Yep, so you can sign in with Facebook, Twitter, or Google. I'll sign in with Twitter. And I'll create a resolution called, there we are. It'll just be -neighbor. So once you've signed in, you can just go to revisolution.com-neighbor, and let me shrink that down a bit.
Does it work on mobile device?
It's supposed to. My designer tells me it does, but it's not something she doesn't have a. I need to make sure she has an iPad and an Android device in front of her so that she can test. Oh, we have 3 participants already. Okay, so I'm submitting this. Looks like I'm the only one proposing changes, though.
Sorry, what's the URL for the document?
Revisolution.com/-naver. And so for those of you, the 3 people who are on the page, you can go to review changes and you should be able to vote on the initial change that I put in. Oh, it looks like there are 3 people right now who are reviewing changes. Good. Oh, and people either voted for or against it. There we are. And someone caused an error in our production database, which you just heard. I'm not sure what happened, but I'll definitely be looking into that. And so we're now on version 1 and creating version 2. I see someone's proposing changes. I'll go propose changes. Okay, looks like I was the first to get my proposal in because 2.1 has been assigned to me. Wow, we now have 7 active participants.
Sorry, I have a question.
Yeah.
Is this a open source project?
Is it one?
It's open source project.
It is not. We're a PBC. We're a corporation. So this is a product. Yes, the code is not open source.
Then can I get any information related to this kind of project?
Can you get any?
Any information to relate to this project?
That's why I'm here.
Technical information.
I'm happy to answer questions. Yeah.
So
We don't have like a big document that describes everything. We have the talk. So yeah, if you have questions about how we make it work, then green factory. Did you have any specifics that you wanted to know about, or?
Actually, we are developing similar tools.
okay.
And we are interested in working situation, right? Working like this.
Okay.
So I want to ask you something to get information to implement like this.
Okay.
Technology.
Yeah.
So how can I get the base technology to implement like this?
How
can you get the base technology?
What do you guys using? And what platform? What's your tech stack?
Yeah, so we're using. We currently are most heavily dependent on TypeScript and Node.js. So everything on both our front end and our back end is TypeScript. And we really like this because it makes writing interfaces where the back end and the front end interact very simple, because I don't know if you've used TypeScript, but it allows you to define what the data formats are. So when you do front end and back end programming, you have some spec which says that the back end's going to return this, and then when you realize you need it to do something else, the spec the code changes, then the spec changes, then the front end changes. When you're using one language for both the front end and the back end, then you can just when you change the definition, the code all just updates automatically. We build everything on TypeScript for that reason. And when we hit performance issues where we really need something that's a little more efficient than TypeScript compiles to JavaScript. So that means we're running JavaScript on our servers. When we hit something that really needs more efficiency, we can take that special little bit of code and code it in something that's more performant. We use Redis for high-speed data storage. We use, because we're running off of AWS right now, we're using DynamoDB for a database, but we have an intermediate database layer so that we can move databases fairly easily because we're not sure whether that's our best long-term solution. But I'd say the key technologies are TypeScript and to a lesser extent Redis.
So you guys are using mainly TypeScript as your major language for your product, and backend is AWS, DynamoDB, and Redis, and maybe some more.
Not really much more. We've really wanted a minimum of dependencies. I'm trying to think if there's anything else that, I mean, whenever we have and on Amazon we have what's called Route 53, which does DNS for us, but that's not really a big part of the product. Oh, looks like we have a new version already. I don't think we have any other, I guess in the front end with TypeScript, we're using React and Redux as our renderer and our state management engine. But that's more of a code library than a system.
Data set, data structure definitions, and it is shared by the front end and back end.
Right.
And that's how it works. So
yeah.
And actually, I have one more question about how you guys are managing that scales.
Yeah.
Well,
it's designed for that scale. We're not managing that scale yet. But yes.
I think that many people, like million people, try to propose something and post something. I think there will be some kind of situation like when I'm working on my drafts, and some changes are just get into my sections. I mean the section that I'm working on. I mean
right. So changes only happen when a new version is released. But yeah, if let's say we're releasing a new version every 5 minutes, let's say that the group works at a speed where we end up with a new version, say, every 5 minutes, and you're working on a change that requires a lot of thought, so it requires 20 minutes, then the versions are going to change underneath you. And so I actually have slides about that. What we do in that situation is that we change the version that you're working on so that any change you made that's now in a deleted section, if you deleted something that's already been deleted, you don't have to worry about it. If you restyled something that's already been deleted, well, that thing's gone. But in the situation where you're making a big, let's say you're writing 5 new paragraphs and everything's changing underneath you. Anything that you've added, we can just preserve. It just stays there while everything else changes around you. So if you're working on a big change like 5 paragraphs, you write your 5 paragraphs, and then you look at what's changed around you, and you say, oh, okay, well, I might want to change this a little bit here. And so within that 5-minute window, that small window between versions, you sort of fix up the details around you. But if things are changing, you can be guaranteed that any text you've written remains. And so that's how we deal with the fact that things may change while you're editing, if you're editing something for a really long time. Does that make sense?
It makes sense, but because of shortage of my English, it is a little bit different from my point. My point was if some participants are trying to make change in a single paragraph or single sentence, then it could be like
Inconsistent.
yes, and what if 3 people or 4 people just made a proposal for a single sentence? Then, I mean.
So that's what we would call a conflict, and so you would resolve that conflict.
So you showed the
2 examples. Yes, those are the most severe conflicts. So at a certain point, we have to decide when things stop being conflicts. So with things in the same sentence, they're likely to be conflicts, even if they're not technically like those. And so we check those for conflicts anyway. And so we have, one of the things that we're still figuring out is at what point do we stop considering them conflicts? Do we consider them conflicts if they're in the same sentence and make sure they get resolved? Probably. If they're in the same paragraph, maybe. If they're in the same section, probably not. So at a certain point, we have to figure out where we draw the line, where we say we're going to check to see whether it's a conflict, and if it's not a conflict, right, people should choose the merge option. So we'll be okay. And if it is a conflict, then only one of them will survive, and that will be okay. So at a certain point, we have to stop resolving conflicts, and that's a line we're going to draw empirically based on what data tells us. So if we start at sentences and then we move to paragraphs, and data shows us that 98% of the things that are in different sentences aren't conflicts, then we'll keep the line that conflicts are within the same sentence. If the data shows us that we need to make it within 2 sentences or within a paragraph, then we'll go from there. So yeah, things can be conflicts without being technically within those rules. Agreed. And we have to resolve them. Yeah.
Thank you. So the system automatically assigning users review the changes?
Yes.
And are they all proposals given an equal chance to be reviewed?
Yes. So, right, the system is designed for fairness, to make everyone feel included, and so that everyone is equal. And so all proposals are treated equally. We do have to figure out what we do if someone, say, runs a script that submits 100 annoying proposals a second. At that point, we may want to limit the number of proposals a person can submit per version, or put some other restrictions on. But the general principle is that all people in the system are treated equally. So any rules we apply would apply equally to them. And we want to be careful about how we apply those rules for who can submit a proposal, because we will have to put some limit on it so that you can't have a script submit 100. But we also want to encourage people to make their proposals small, because it's better to put 3 small proposals in than to combine them all at once, because if you combine them, there are more likely to be conflicts. And so we have to figure out exactly where to draw the line there, which is another one of those open questions we'll figure out with empirically, but where we have a number of heuristics that we think are easy to try, and most of them should. I'm guessing there'll be multiple different options that work pretty well. Thank you. Good question. Yeah.
Internally, are you developing a version control system from scratch, or are you using some kind of version control system such as Git or SVN?
We are not. We would not call ourselves version control in some sense, but yeah, there's the question of how do we diff. Because I mean, the key thing that we're doing here is diffs and then merges. We can't use Git because Git only works for text, and in fact, most of the technology out there only does text. It does not do rich text. So if you think about the stuff that Google does or that Microsoft does, they don't publish rich text diffing tools or rich text merging or any of that. And so there's nothing we can use from this the existing open source world, like the stuff that's in Git, because it doesn't work in rich text. So we have our own language of describing changes that are rich text based. But we do build that on top of an open source diffing library. That diffing library is very rudimentary. It does character level diffing. We built word level diffing. There are lots of specific rules you want to do with diffs that are not inherent in the published algorithms. So, for example, do you treat a word added, a word deleted, a word added, a word deleted? That's really, right, your diff engine might come back with that, but that's really actually a sentence added and a sentence deleted that comes out in the diff in these weird ways. So even when you have a diffing library underneath you, you need something to translate it into a form that's more human readable. Because what you get back from a diffing library is usually something that's a minimum edit distance, but is not designed for minimum cognitive distance. What's the most user-readable diff rather than what's the minimal edit distance. Okay, there are no other questions. I'm very happy to talk to you more about how the tech works offline if you like. But thank you very much.